So our topic is data center consolidation, and we'll be conducting a cost benefit analysis of data center consolidation using virtualization. So this is the outline we are going to follow in this video. So basically, what is a data center? A data center is a physical or a virtual infrastructure used by enterprises to house computer, server and networking systems and components needed for the company's IT needs, which typically involve storing, processing, and serving large amounts of mission critical data to clients in a client server architecture. A data center often requires extensive redundant or backup power supply systems, cooling system, redundant networking connections, and policy-based security systems for running the enterprise's core applications. Data center management involves ensuring the reliability of both the connections to the data center as well as the mission critical information contained within the data center's storage. It also entails efficiently placing application workloads on the most cost-effective computing resources available. Data centers have Data centers have traditionally been thought of as large-scale physical environments where an extensive number of computers and servers are housed. The software-defined data center has now created a new breed of virtualized data centers and cloud-based data centers that extend a company's on-premise infrastructure to off-premises sites. These virtual data centers can serve as a bridge to the enterprise's private data center in a hybrid or a blended fashion, or the company can completely offload its data center operations by relying on a public data center from a third-party service provider like Amazon, Google, or Microsoft. Now, typically, a data center comprises of five main components. The first is telecommunication system. These consist of the networking components and maintain the data center's connection to the internet. Second are the storage systems. These are the main systems on which all the data center's data is stored. HVAC systems stand for heating, ventilation and air conditioning. These are responsible for maintaining the data center. Redundant and backup systems maintain the data security and prevent loss of data. Security system consists of both on-site and external security to secure the data from external interference. Shows the This diagram shows the typical power consumption in a data center. As we can see, the core IT equipment accounts for only about 30% of the total power consumed, and the rest is used in cooling the systems and maintaining and running the other systems. A large amount of energy is converted to waste heat. Now let's have a look at some of the statistics. In 2013, US data centers consumed an estimated 91 billion kilowatt hours of electricity, which is a lot of energy. By 2020, it is expected to rise to 139 billion kilowatt hours. The primary issues faced by current data centers are that the server energy consumption has continuously increased from 50 watt per hour to 250 watt per hour since 2000. If it continues in this way, the energy cost will exceed the server cost if this trend does not change. In this graph, we can see that the new server cost versus the power and cooling cost. In 1996, the new server cost was many times more than the power and cooling cost. But in 2010, the power and cooling cost is very near to the new server cost. The motivation to conduct data center consolidation is to reduce the power consumption basically. Servers in data centers waste a substantial amount of energy. The reason is that servers are deployed and configured for peak capacity, performance, and reliability, usually at the expense of efficiency. Such waste unnecessarily increases capital and operational expenditures. This results in finite resources being exhausted. Now the related work. This, these are the steps to be followed for data center consolidation. The first step is virtualization. Second is storage virtualization. The third consists of data migration. Fourth step is backup. And the fifth step is network consolidation. Now, data center virtualization can reduce the cost of facilities, power, cooling, and hardware, simplify administration and maintenance, and give us a greener IT profile. The first key benefit of data center virtualization is less heat buildup. Millions of dollars go into research and design of heat dissipation and control in the data center. But the fact is that all those servers generate heat. The only way around that is to use fewer servers, and this is achieved by virtualization. Virtualize the servers, and we are using less physical hardware. Using less physical hardware leads to generating less heat. Generating less heat leads to a host of issues going away. The second is reduced cost. Hardware is often the highest cost in the data center. Reducing the amount of hardware used, we can reduce our total cost. But the total cost goes well beyond that of hardware. Lack of downtime, easier maintenance, less electricity used, over time, this all adds up to a significant cost saving. The third point is faster redeploy. When we use a physical server and it dies, the redeployment time depends on a number of factors. Do we have a backup server ready? Do we have an image of the server? Is the data on your backup server current? With virtualization, the redeploy can occur within minutes. Virtual machine snapshots can be enabled with just a few clicks, and virtual backup tools such as VM and VMware redeploying images will be so fast that the end users hardly notice the issue. The other benefits are easier backups. We can easily do full backups of our virtual server and take snapshots of the virtual machines. These virtual machines can then be moved from one server to another and redeployed easier and faster. Snapshots can be taken throughout the day, ensuring much more up-to-date data. And because firing up a snapshot is even faster than booting a typical server, downtime is dramatically cut. Better testing. The virtual environment is the best testing environment available. If we make a mistake, not all is lost. We can just revert back to a previous snapshot and just move forward as if the mistake didn't ever happen. We can also isolate these testing environments from end users while still keeping them online. When we have perfected our work, we can deploy it as live. It also has no vendor lock-in. One of the most important thing about virtualization is the abstraction between software and hardware. This means that we don't have to be tied down to one particular vendor. The virtual machines don't really care about the hardware they run on, so we are not tied to a single vendor, type of server, or even a platform. This virtualization also leads to better disaster recovery. When the data center is virtualized, up-to-date snapshots of our virtual machines can quickly get backed up and running. And if any disaster strikes the data center itself, we can always move those virtual machines elsewhere. Having this level of flexibility means that your disaster recovery plan will be easier to enact and have a much higher success rate. Now coming to single-minded servers. When we have all-in-one services, we are looking at a single point of failure and also have services competing with each other for resources. Those all-in-one servers are purchased to save money but end up costing much more. With virtualization, we can easily have a cost-effective route to separating your email server, web server, database, etc. By doing this, we will enjoy a much more robust and a reliable data center. Last point is easier migration to cloud. With the move to virtual machines, we are much more closer to enjoying a full-blown cloud environment. We may even reach the point where we can deploy virtual machines to and from your data center to create a powerful cloud-based infrastructure. But beyond the actual virtual machine, the virtualized technology gets us closer to a cloud-based mindset, making the migration all the more easy. Thus, we see that virtual machines offer a powerful way to help relieve the typical headaches that plague administration day in and day out, and all the data centers which haven't already begun to make use of virtualization, it's time to start.
The related work regarding our project is the first one is Restream, that is real-time and energy-efficient resource scheduling in big data stream computing environments. That is given by Davis and et al. That in 2015. The author presented two additional models on the Tower's Storm. The first one was a critical vertex-based scheduling, and second is energy-aware consolidation. The demerits of this work was it didn't focus only on managing scheduling algorithm to improve energy efficiency. The other related work was T-Storm, Traffic Aware Online Scheduling in Storm. This was given by JXU et al. In 2014. It explains that T-Storm allows hot swapping scheduling algorithms and adjusting scheduling parameters on the fly, and it is transparent to Storm users. The demerits of this work was it didn't focus on energy aware policy. The related work, the third one is reference architecture and classification of technologies, products and services for big data systems. This was given by Pekka Pekkanen et al. In 2015. The aim is to facilitate architecture design and technology or commercial product service selection in the construction of big data systems. The demerits was it didn't consider and address the real-time data. Another related work was a knowledge-based platform for big data analytics based on published, subscribed services and stream processing. This was given by C. S. Peter et al. In 2014. It presented technological framework that may become the core of an open source solution, and it helped in supporting the analysis or processing of huge data volumes across multiple heterogeneous systems scattered throughout the internet. The demerits were it didn't focus on the energy aware policies. Another related work was performance and energy efficiency of big data applications in cloud environments. It was a Hadoop case study given by E. Feller et al. In 2015. It discusses on the application execution time, energy consumption, and application progress correlation with power consumption using the Hadoop framework. The demerits were it only focused only on the batch processing for big data to improve the energy. Now comes the theme of our project. The title of our paper was Cost Benefit Analysis of Data Center Consolidation Using Virtualization. The theme consists of a flowchart. The main part of the design is the internet core access, which includes the various ISPs that connects it to other platforms such as XSP, supplier partner, remote office, wireless networks, and home networks. These are all connected by the various ISPs using LAN networks. The main part connected is the enterprise system, which deals on the directory, security, policy, and management. It is a software OS platform. The enterprise consists of various other aspects such as tier 1 edge apps, tier 2 apps, tier 3 database servers. The tier 1 edge apps consist of caching, proxy, FW, SSL, and various others. The tier 2 apps contains the application JM, file print, EPP, SCM, and CRM servers. The tier 3 database servers consist of the database, which is a very important part of the enterprise system, and the middleware data mite service. The other part connected is the FCI IP SAN, which plays a major role in the working.
The objectives of the paper are as follows. It includes consolidating enterprise data center services, optimizing the use of scalable and secure servers. It also includes centralizing server support for infrastructure as a service, that is IaaS. It aims at improving power utilization and reducing cost and maintaining performance. A design consists of data center asset, key metric, consideration of constraints, and they are dependent on various consolidation approaches. The data center asset consists of servers and mainframes, storage, racks, data center and data center flow space, IT energy efficiency. The key metric consists of average server utilization, average storage utilization, average rack utilization, total IT flow space, that is in square feet, and the energy power efficiency, that is PUE, and kW, that is kilowatts. The constraints or the considerations are that the facility lease and term agreements. We also need the app requirements, that is performance, security, integration. It also includes OS, platform, and standardization. Also, there's a three-tier classification: geographic location, personal relocation. And the consolidation approaches we follow are decommissioning, centralization, site consolidation, virtualization, cloud computing alternatives. The data consolidation involves the following design. First one is the virtualization, then comes the storage virtualization, data migration, next is backup consolidation and network consolidation. This is the basic uh, design of our paper. It includes the VMware vSphere. Both are connected to each other through vSphere replication. The VMware sphere, it's connected to the to various VMwares which are intact connected to VMware vCenter servers and the site recovery managers. The VMware sphere also connected to various data centers, and similarly the storage replication is done. So the result is that virtualizing the current data center includes numerous issues. In the event that physical arrangements are not good, you should remunerate by purchasing equipments to upgrade your ability. The more servers you merge, the more specialized bolster you will require. At times, in spite of uniting servers in a sharp edge environment, the equipment is not virtualized. Now and then, a solitary virtual machine keeps running on a solitary sharp edge server, while the equipment server can run numerous virtual machines. Thus, the ideal use is required to accomplish high accessibility of both the server equipment and the VMs. So data center modernization in short includes cloud, information, social and mobile, which further includes data center consolidation, virtualization, software design defined anything, IT service continuity, web scale IT, which further includes integrated systems, storage, server, power and cooling and networking. So we'd like to conclude by saying that data center consolidation through virtualization has potential for both high cost saving and minimized deployment and downtime for disaster recovery. To successfully achieve these, it is essential for an organization to conduct first an initial study on strength, weakness, opportunity and threat analysis. Many financial, operation and technical and security related issues play a vital role in formulating strategies for data center consolidation and recoverability. In addition, deciding whether the data center consolidation option to choose is equally important in steering an organization towards success.
The references that helped us to build this paper is the first one is by GC Decca, which is titled as Cost Benefit Analysis of Cloud Computing in Education. The second is Energy Efficient Guidelines and Best Practices in India Data Centers, which was given by Government of India in 2010. Third one is was by J.G. Kumi et al. That is titled as Assessing Trends in the Electrical Efficiency of Computation Over Time. The final report to Microsoft and Intel that was given in 2009. The fourth is Lifecycle Costing for Data Centers that explained the determination of the true cost of data center cooling. White paper. This was given by Liebert Corp in 2003. The fifth one is by J. Baliga et al. It was titled as Green Cloud Computing, the Balancing Energy in Processing, Storage and Transport. This was a IEEE paper that was published in 2011. The sixth one is Data Center Consolidation. This was given by the UK government in June in 2010. The PDF is available on the net. The seventh one is was given by A. Greenberg and D.A. Malls. It was titled as What Goes into a Data Center. This was researched by Microsoft in June 2009. The eighth one was by Esdata and IMEA. This was a World Information Technology report that was published in 2010 to 2011 in the World Economic Forum in 2011. Thank you.
In the end, we like to thank Rajsekhar Babu sir for guiding us in studying this report and the paper.